Welcome back, students. This is Megasham Raju, Engineering College Bikaner, Assistant Professor, Mechanical Department. As we have seen in the previous lecture, Vernier caliper and its types, then micrometers, outside micrometer. Now coming to the types of the micrometer, in that the first type is disc micrometer. Here you can see that there will be a two disc attached here, which are generally used to measure the span of the teeth of the gear. As the disc is limited to certain gears only, there is an higher chances of errors over this micrometer. Okay, so this is the description, and you can see the real micrometer in this slide like this. So this is your gear, and you can measure the span between two teeth, and you can even measure the span of the one teeth also. Now this is how the disc micrometer look like. This is a digital disc micrometer, and this is your lock nut. After spindle movement you can lock it here, and this is where the digital reading happens. It is an IP rated, so it can use in dust as well as in water. Now the next micrometer is screw thread micrometer. In this screw thread micrometer, it is mainly used to measure the pitch of the screw, and the anvil contains the V-shaped cut here and the spindle conical shape. We can change these anvils whichever measurement we required, we can change, and for every micrometer its least count will be displayed here. So the description is like this, and the real screw thread micrometer will be like this, and this is where the anvil, you can change these anvils faces whichever you required. There will while you are buying the micrometer, the company will be provided with a bunch of anvils with the desired thickness of this V shape, and this is where the thread, and you can measure the pitch of this thread. This is what the screw thread micrometer is. Now coming to the next micrometer, dial micrometer. This micrometer is generally used for the comparison in a mass production. Either you can say this whatever the measured quantity can go into the mass production, or it can be rejected. So here you can see the dial micrometer normally has an accuracy of 1 micrometer and repeatability of 0.5 micrometer. So the dial micrometer generally looks like this. So this is where the dial gauge will be there, and this is your lock nut to lock the spindle, and this is your main scale. This is where the readings of the micrometer, which differs with a vernier caliper ratchet, and this represents the how much pressure you are applying over this job, so that you can avoid the damage over the job. Now coming to the next micrometer, blade micrometer. So the anvil and spin faces are in the form of the narrow blades, and generally used to measure the screw thickness, slots, keyways, and the blade thickness ranges from 0.75 mm to 1 mm. And the specialty of this micrometer is the spindle doesn't move here. So because as it doesn't rotate, not sorry that I have told the spindle doesn't move, it means that the spindle doesn't rotate here. As it won't rotate, non-turning spindle working against the rotating screw, it is vulnerable to rapid wear and tear, so care should be taken. This is how the blade micrometer looks like. So you can see the thickness. These are used to measure the grooves, keyways in that perception of the application. So coming to the vernier micrometer, in previous lectures we have seen the vernier caliper. Its least count is 0.01 mm, and measurement using a simple vernier caliper, how difficult it is to measure the dimensions of the job. Next, the main disadvantage of the micrometer is it doesn't have much range when you compare with the vernier caliper. In the similar way, the disadvantage of the vernier caliper, it is having a parallax error, and there is a high wear and tear of the jaws, upper and lower jaws, whatever you take, and angular errors are also higher in vernier calipers. Now the advanced instrument vernier micrometer, in this we will be adding a vernier scale to the barrel scale, whatever you may call it. I'll be calling this as a main scale, and this as a vernier scale, and this is the thimble scale, right? So the advantage of this vernier scale adding to this micrometer is we will get the least count, the 10th part of the vernier scale, which is nothing but 1 micrometer or 0.001 mm, and it is excellent proposition for any precision workmanship, in the sense you will get an precise value of the job. As I have discussed, divisions on the vernier scale have to be read in conjunction with the barrel scale. So how we need to read these vernier scale is, whichever coincides with the thimble scale, we need to multiply with the least count, proposition of the least count with the vernier scale, and adding the main scale reading, you will get the measured value. I'll be discussing clearly in the next slide, taking one example. Yeah, if in case if this reference line doesn't coincide with any reading, then how you need to consider it. Yeah, however, if none of the division of the thimble coincide with the reference line, we need to examine which division on the thimble coincide with one of the division of the vernier scale. That's what. Here, if we just consider one example, the main scale reading, if you just see 12.5 mm is the main scale reading, and the one forward movement of the spindle will give a main scale representation of 0.5 mm. And for example, if my thimble is having 50 divisions, then the least count can be calculated by 50, 0.5 divided by 50, which is nothing but 0.01 mm. Now these 0.01 mm will refer with this vernier scale of 5 divisions, then you will get the one representation of the vernier scale as 0.01 by 5, 0.002 mm. So now the total reading will be 12.5 as my main scale reading plus, and if you just see here, the reference line doesn't coincide with any of the reading in the thimble. So it is in between 24 and 25. So I'll be considering the least one, 24 multiplied by the least count of the thimble or the micrometer, which is nothing but 0.01, plus, if you just see here, the 15 is coinciding with the Vernier scale's 4th position. 4 into how much division, equivalent division with the least count is 0.002. Then you will get an exact value as 12.748 mm, which is the best in industry. So Vernier micrometer is very good if you just want to measure the values in micro level. And one more thing you need to observe here is the scale might vary from 0 to 5 or 0 to 10 based upon your application, right? Now coming to the digital micrometer. So as we know, we have already discussed the digital vernier caliper. What are its advantages when you compare with the manual vernier caliper? Similar way, for this digital micrometer we are having advantages like with one button we can convert inches to millimeter, millimeter to inches, or British to any other unit to British units. And we can connect the digital micrometer, which is looking like this. We can connect this digital micrometer to the printer or to the computer, and we can process the data. What is meant by processing is we can take the mean, we can observe how much deviation from the required value is happening. And with the one button pressing, you can make the spindle set to 0, and the instrument can be used to inspect a job with a specified tolerance. And the spindle is made up of generally the stainless steel, and measuring faces are carbide tipped for a longer life. And one more best thing in this digital micrometer is you can get the feedback of the pressure over the job by just pressing the button here, which will be given by the ratchet, in which there is a feedback mechanism through some control system. And these are the functions: on off button to convert inch to millimeter, millimeter to inch, and to set the display to 0, and to hold the measurement taken until the push button is operated again. Origin to set the minimum value for the micrometer depending upon its size. Micrometer count commences from this value. And the alarm where if the voltage is very less. That's all, guys. So in the next lecture I'll be discussing the comparators, and I'll be giving in PDF notes for the slip gauges. So you just follow that, and thank you for listening the lecture.